All right, 10th grade, this is your third Algebra 2 class. I am actually starting section 4.3 of your textbook, which is on page 252 and 253. I'm actually going to show you these quick examples very quickly. I know it sounds redundant, but that's what I'm going to do. Show them to you very quickly and then direct you guys to some guided practice. This is me, your favorite teacher. You know I am, so I'm not going to go too much into the pleasantries. Let's get started. We are actually going to solve quadratic equations, but we're going to solve them in the form of x squared plus bx plus c equals 0. And I know that sounds complicated, but all it is saying that I'm going to factor these equations when my leading coefficient, or when the x, has a 1 in front of it. Now, how do I factor this out, or how do I make it simpler? It's very easy. When I have an equation like this, and this is example number 1 on page 252, I'm going to look at the x squared. Now I know, and this is for you guys to understand, that x times x is always going to equal x squared. Okay, so that's the first thing, just x times x. Next, I'm going to look at these two numbers, at negative 9 and 20. Since the leading coefficient is a 1, or in other words, since the number here is a 1 and no other number, I'm going to think of two numbers that when I add equal negative 9 and when I multiply equal positive 20. If you're thinking 4 and 5, you're correct. And I'm going to say x minus 4 and x minus 5. And that's it, guys, because negative 4 times negative 5 is positive 20. And negative 4 plus negative 5 is negative 9. And that's it. That's it. I don't need to do anything else. I'm done with the exercise. That's it. It's example 1A. If you're expecting more, don't. That's it. All right. So now I'm going to look at B. I notice again that the leading coefficient is a 1, or in other words, that there's no other number in front of this x that isn't a 1, which means I have to think of two numbers that when I multiply equal negative 12, but when I add equal positive 3. So this is a tricky one. So what you want to do is think of factors of 12. What numbers, when I multiply, equal 12? Well, 4 times 3 equals 12, and 6 times 2 equals 12. But when I add any of those two numbers, am I actually going to get a positive 3? The answer is no. So what do we say? We simply say that this exercise cannot be factored. Later on, we're going to see that it can be, but for the time being, we're only going to say cannot be factored. Why? Because there's no numbers that when I multiply equal negative 12, that when I add equal positive 3. So I cannot factor it using this method. So that's it. That's example number 1. Very quickly. Once again, whenever I'm factoring numbers where the leading coefficient is a 1, is an x squared or a 1x squared, I'm going to think of two numbers that when I add equal negative 9 in this case, and when I multiply equal positive 20, in this case it's negative 4 and negative 5, because negative 4 times negative 5 is positive 20, and negative 4 plus negative 5 is negative 9. And that's it. And then I'm going to do the same thing for this one. But since when I factor 12, none of the factors of 12, when I add them equal positive 3, simply say cannot be factored. So I'm going to let you look at that real quick. And now we're going to go to the second page, or page 253. Page 253, ladies and gentlemen. Above page 253, we have what's called special factoring patterns. And this is very common. The first one that we're going to see, because it's a difference of squares. And a difference of squares is actually the same thing as saying a squared minus b squared, which equals a plus b times a minus b. And then we have a perfect square trinomial, which is a squared plus 2ab plus b squared equals a plus b squared. And a difference of trinomial, which is a squared minus 2ab plus b squared equals a minus b squared. Now I know it sounds very complicated, but it's really easy. Let's look at the first example, example 2a. Now what is a and what is b? I'm going to identify a as the first term, in this case the x squared, and b as the 49. Now this is a difference of squared, which means that a squared minus b squared is supposed to equal a plus b times a minus b. But how do I get the a plus b and the a minus b? Very simple. What you're actually going to do is you're going to look for the square root of x squared and the square root of 49. The square root of x squared is x. So I say x plus the square root of 49 is 7. And you've got it. I just say x minus 7 on the other side. And that's it, guys. So the only thing I did, and the only thing you're going to do basically is to look at your first and last terms and actually get the square root of them. And by getting the square root of them, I can just plug them into the formula. So again, guys, A is x, B is 49. If I want to convert them into the formula, into the difference of squares, I simply look for the square root of x squared, which is x, and the square root of 49, which is 7, and then I just plug them in. And x plus 7 and times x minus 7, or a plus b times a minus b, which is what I did here. Very simple. This formula here, it says d squared plus 12d plus 36, which is the second problem. It's the same thing as saying this. A squared, d squared is actually a squared plus 2ab plus b squared. So this is actually this. So how do I convert this into this? Very simple. I'm going to look for the square root of d squared and the square root of 36 because they both have perfect square roots. So the square root of d squared is d, and the square root of 36 is actually 6. Let me do it down here. The square root of d squared is d, the square root of 36 is 6. So all I do is I plug the d and the 6 into this formula. And I'm simply going to say that this equals d plus 6 squared. Very simple. All you need to do is just memorize who's A and who's B. That's pretty much it. That's what I did for the second one. So d is the same thing as saying a squared. The 12d is actually the same thing as saying 2ab, and the 36 is actually the same thing as saying b squared. So what I do is I look for the square root of the d squared, which is d, the square root of 36, which is 6, and then I just plug them into this. Instead of writing a plus b squared, I say d plus b plus 6 squared, excuse me. And that's it. Now the last one is the same thing, guys. Z is actually to be a squared. The 26 is actually the same thing as saying 2ab, and the 169 is actually the same thing as saying b squared. So what does that mean? That means I'm just going to look for the square root of z squared, which is z, and the square root of 169, believe it or not, it has a perfect square root. It's actually 13. And then I'm just going to plug this into this formula, and I'm just going to say it equals z minus 13 squared, and that's your answer, guys. Very simple, very easy, nothing out of the ordinary. Just identify who's your A and who's your B and plug them into the formula. I know I'm recapping real quick. I know that x squared minus 49, this is my A and this is my B. So I find the square root of x squared, which is x, the square root of 49, which is 7, and then I just plug them into this formula. And x plus 7 times x minus 7, and that's it. Nothing more, nothing less. And I'm going to do the same thing for the second example, for B. You have d squared plus 12d plus 36. I know that this is A, I know that this is B, I know this is 2ab, since it's all plus. That means I get to plug them into this formula. And how do I do that? I do that by simply finding the square root of d squared, which is d, finding the square root of 36, which is 6, and then plugging them into the a plus b squared. But instead of saying a plus b squared, I write d plus 6 squared. And finally, I do the same thing. Z squared minus 26z plus 169. This is a. This is 2ab, and this is b squared. So again, I just look for the square root of z squared, which is z, the square root of 169, which is 13, and then I plug them into this. And instead of writing a minus b squared, I say z minus 13 squared. And that's it, guys. That's it. Those are the first two examples of section 4.3. Now I'm going to direct you to the guided practice. So your next assignment is to go to guided practice on page 252 and answer problems 1, 2, and 3. And then go to the guided practice on page 253 and answer problems 4, 5, and 6. Do those as well as the ones that I assigned yesterday, and then email me those assignments. Remember, the email is jmarquez@fbspr.com or mr.j.marquez84@gmail.com. And this is your favorite teacher saying goodbye, good night, stay safe, and I will see you soon.